Puneet Shetty, VP of Product, Celona. Have been with the company for the last 3 years since the launch of the product. And then with me today, we have Prince Jose. He's Director of Product, and he's the one who's been leading our charge from a RAN portfolio perspective. So a lot of things that you see on the table here are our labor of love from Prince. So he'll be talking about that a little bit later. So what we are going to do today is take the journey forward. And the journey's actually started, as was mentioned earlier, at MFD 4, 2019. So we had Rajiv and Mehmet actually introduce the company to all of you. The following year, just before we went FCS and GA, unfortunately, it was COVID, so Mehmet had to give you a sneak peek of the product that was about to be launched over Zoom. Following year, MJ, one of our TMEs, and myself, we ran a few cool demos on the platform, including eSIM. We were able to actually show eSIM running on a private wireless network for the first time. And then last year, and Avril was just mentioning to me, she still remembers the presentation from JR and Kevin, where they actually brought up Celona private 4G network from scratch to kind of give you a sense of what it takes to build a network. And it's not as ominous as it's made out to be, right? And a lot of that is the work that Mehmet and engineering team and the product team has actually put together to make it palatable for the enterprises. So to take the journey forward today, Prince and I, we would initially, maybe there are some new folks in the room, we'll give you a quick overview of what Celona is, who Celona is. We will go into specific real-world deployments where we have actually seen a private 4G network flourish in the US, some learnings that we have had, and how all of those learnings have made their way back into the product. So we'll kind of go into a little bit of a show and tell from a demo perspective. I will then introduce our 5G product portfolio. So we just launched our private 5G access points earlier this year at MWC. Indoor, outdoor, multi-mode, 4G and 5G, a lot of exciting stuff around that. And then we'll have Prince actually demonstrate to you bringing up a 4G and a 5G network together on a converged core. So we'll show you that, we'll show you devices, and then, as always, we'll show you micro-slicing on a 5G network. So that's the plan for the day, and let's hope the demo gods are smiling at us, right? And we also have, sorry, Mehmet, we also have Mehmet, our CTO, who's also joined us remotely, and he will jump in as needed. Mehmet, anything you want to say to the folks here?
Hi, everyone. And looking sharp there, Puneet.
Oh, thank you, Mehmet. Mutual admiration club there. All right, let's jump in. A lot of content to cover. All right, so just for folks who are not familiar with Celona, so Celona is a 4-year-old Silicon Valley startup. We have been focused on bringing private wireless network infrastructure to the enterprise. That's been our mantra and motto from day one. So we haven't taken something that was built for macro networks and tried to fit it into the enterprise context. And if you look at the co-founders and the rest of the team here, we're all a mix of folks who have done cellular, like Mehmet, who's kind of been in cellular all his life, and then folks like Ravi, Rajiv, Vinay, who are some of the early engineers at Aruba Wi-Fi. So we come from a background of people who understand enterprise network infrastructure. You throw in a mix of a cellular guru like Mehmet, and what you get is a product that is tailor-made for the enterprise. And we will talk about the details of what that entails. So again, our journey has been validated by tier 1 investors in the Silicon Valley, strategic investors like Qualcomm, NTT. We have strategic go-to-market partnerships with the likes of Verizon, NTT, who are actually taking us to their customers. And then, of course, a whole slew of customers, not all of them we can really talk about, but here is a flavor of the different customers and different verticals where we have been successful. All right, and the need for private wireless within the enterprise, a lot of it, at least for the last 3 years from our perspective, has been driven by what internally at Celona we have coined as uncarpeted or non-carpeted enterprise. So this is the industrial verticals such as manufacturing, logistics, transportation, construction, oil and gas, uh, areas where you require to provide connectivity typically in a large outdoor setting, and the RF environments are not very, very friendly, and hence the existing solutions that they have just don't cut it. You have another set of use cases where warehouses, manufacturing floors are going through a level of automation that requires them to introduce devices and applications that are asking for a certain level of predictability, reliability, and SLA that their current network infrastructure is not able to provide unless you actually wire these things. And obviously, in terms of automation, they're trying to cut the wire as much as possible. And all of these things are basically making it a burning platform for these specific verticals that I just mentioned and leading them to look at alternatives such as private 4G and private 5G. And that's where Celona comes in. So we, from our day one, have basically built and created a solution from scratch for those verticals. We have created a turnkey solution that has all the different pieces that you would need to run and operate your own private wireless network. This includes the SIM cards, physical and digital eSIMs that can go on the device. We make them available to our customers. The access points, now we have a portfolio of 4G, indoor, outdoor, 5G, indoor, outdoor, access points available not just for the US market, as well as the global market now. The Celona Edge, it's prepackaged in an appliance today. This is where all the Celona core services are running, 4G core, 5G core, the spectrum management services, the SON algorithm, which is basically programming the access points in a dynamic manner. All of those are running as microservices on this Celona Edge. Both Celona Edge and the Celona AP are typically deployed on-premise within the customer's network. And then the Celona Orchestrator is the one that is hosted in the cloud. And this provides the window for enterprises to basically set up their network on day 0, day 1, and then operate it at scale on day n. So all the operations that one would require is all built into the orchestrator. And from a customer point of view, they don't really have to touch the AP or the Celona Edge. It's all done via zero-touch provisioning by the cloud. And all of this has Celona software footprint across the board. And that's what allows us to kind of deliver some key value features such as microslicing, and I'll talk about that in a little bit. But more importantly, be able to deliver a very, very coherent operational model, which from an enterprise perspective is not very, very different from how they would operate their Wi-Fi network. And it starts from what we call our radios. We call it access points. It's not a G node B or E node B. It's an access point, and the radio technology kind of follows that.
And why did you, by the way, I appreciate using AP instead of the proper terms. What was the driver behind that?
I think it's the audience that we are going after, right? The audience that we are going after from day one has always been enterprises, right? We were never going to sell it to a macro network. They were going to be a go-to-market channel for us, but the end user of our product was always going to be enterprise, and hence we started with that mindset. Now, some of the thinking has evolved, and I'll talk about that. Like, for example, previously, we were abstracting a lot of the cellular details from the audience. But over time, we are seeing that cellular expertise is kind of being injected into the enterprise, and we are kind of peeling the onion and exposing more and more management and controls in our orchestrator for that audience. All right. No conversation about Celona is complete without us talking about microslicing. This is a crown jewel, and actually, Prince has a really cool demo for us at the very, very end using the 5G network. So with microslicing, one of the key reasons why enterprises are looking at a cellular network or a private wireless network, is because they want to deliver an SLA, a reliable, predictable SLA to their mission-critical applications. And cellular allows them to do that through the idea of slicing. But typically, the way slicing has been used in the macro network, it's typically done at an enterprise level because macro operators want to create a slice for an enterprise and kind of charge a premium for that. When you think about enterprises, they don't think about their entire application flow. They look at devices, and critical applications that are running on the network. How can I deliver an SLA to each application, each device? And to be able to do that without touching each device, creating APNs on the device, and managing all of those through a policy definition within the network, which is done in the orchestrator. So as a user, I will only define the policy in the orchestrator as to what devices are critical to me, what applications are important to me, what kind of QoS do I want to deliver to those applications and those devices. You define those policies at that level, and then the AP and the edge, the orchestrator pushes those policies down to the network, and the AP and edge orchestrate those policies for those respective applications and devices. So all of that is done from a device perspective. It's completely zero touch. You're managing all of that from the network. And what that allows you to do now, you have your video application, you have your voice application, you can create an expressway on the network, and irrespective of how much contention you have on the network will attempt to deliver the SLA for those applications, even when there is contention on the network. And then the other part of it, so one part of it is the QoS over the air, QoS from a compute perspective. So the edge here, Celona Edge can spawn up additional compute resources from a data plane perspective as you see a rise in traffic. And then you can take that traffic coming from devices, coming from device groups, and put it in the respective network segment and kind of adhere to the security policies that the enterprises might have in place. So all of this, so MicroSlicing kind of brings in the QoS aspect of it. It also brings in the network and security segmentation aspect of it and ties it all together in terms of a policy definition that the user does in the orchestrator. And from a customer's perspective, these devices, they probably already had on the network even before they introduced a Celona private wireless network. The VLANs and the segmentation, they already had defined even before they introduced the Celona private wireless network. So as they introduce this new access network in between, everything to the left and the right can continue to operate exactly the same way as it did before, and you can now deliver application SLAs to these critical devices and applications. And again, as I said earlier, all of this will become real as we go into the orchestrator. Prince will actually define those policies, show you how it's done, and then show you how the SLAs will be adhered to in light of contention in the network. All right, so switching gears a little bit out of the product, but more into some real-world deployments. I'll talk about 3 specific deployments. These are production deployments where Celona is deployed. These are in the US, so they're all private 4G at this time. We are seeing new private 5G deployments happening as we speak. I will be talking about a large oil and gas refinery. We'll be speaking about a manufacturing automation use case. And then one of my favorites, which I feel is a poster child for private wireless, this is a warehouse automation where these little bots are moving around at like 30 miles per hour. And what it takes to actually operate a network with that level of high-speed mobility is something that I will speak to. And again, please feel free to interrupt if you have any questions along the way. All right, this large oil and gas refinery, it's quite large. It is 0.54 square miles. For perspective, I believe it's 260 football fields. I don't know if it's soccer fields or American football, but you get the point, right? So 260 football fields. Currently, we have around 10 outdoor access points providing connectivity to that entire area. So something like, this is a 5G outdoor access point, but something similar on the 4G side is actually deployed with the external antennas and providing connectivity to that area. The typical use case here, the customer pain point was large outdoor space, RF environment not very friendly. How do I provide connectivity to this entire area in a reasonable manner so that my CapEx and OpEx don't just blow out? So reliable outdoor coverage is the driving factor. Some key use cases that they had in mind was today, they do this site safety inspection using a manual process, pen and paper. Now they wanted to give iPads to their associates. So as they go around the property for the safety and inspection, they can actually use. Again, very, very simple use case, nothing very flamboyant, but this simple use case is driving a significant business outcome that I will speak about in just a little bit. The second use case was a lot of IoT sensors that are constantly polling data from their instruments and then making sure that it's kind of adhering to their safety standards. How do they take that data and then provide connectivity to these IoT devices and send it back to their central database system where they can actually monitor all of that? So they are, obviously, these IoT sensors are legacy IoT sensors. They don't have native support for private wireless. So they are using a Sierra RV55, which is a gateway or a router, a cellular gateway or router to which these IoT sensors can connect, and that can then connect to one of the outdoor access points that is actually deployed there.
I got a quick question there.
Please.
Oil and gas. I know your devices are not C1D2 compliant. Did you put them in an EMA enclosure, I believe?
Actually, we do have a C1D2 compliant. So this 5G.
This one is?
This is a C1D2. Even on the 4G side, we have a C1D2 version available, which for specific use cases, we use that.
Okay.
Not for all, but for specific ones. It does come at a premium, but yes, that's something that we have available.
Cool.
And all the 5G access points, given our learnings, that's one of the learnings.
So you did, okay.
Given the learnings and the kind of deployments we are seeing, the ruggedized deployments, all of our 5G outdoor access points are all C1D2 certified.
Okay. As you're talking through this use case, I guess my question is is there any provision for CBRS infrastructure that moves along with the use case? I'm thinking about connectivity, for example, on a barge, right? Maritime, I'm going down the Mississippi and I need to connect to a thing way out on the other thing at the end of the barge. Is that something where if that AP is moving,
yeah,
right, that's a problem, right?
Yeah, so Mehmet, I know you are dealing with some of those use cases with drones and others where people want to move the connectivity point. So Mehmet, do you want to speak to that for a little bit?
Yeah. I mean, this is a great question, Sam. And right now, the regulation is not permitting the base station to be mobile.
Okay.
That's still the case.
Okay.
Mehmet, but is there consideration on changing that maybe, or?
I mean, there are discussions.
Okay.
There are discussions, but it's not there yet.
Okay.
Today it's fixed
And
that.
there are other spectrum options opening up, like 3.1 gigahertz is another one in the horizon. So all of these learnings are coming into that. So my hope is down the road, maybe in a few years, those use cases can be handled, but not today.
So I think to summarize, in the CBRS spectrum, it's unlikely to happen based on the conversation so far. But as additional spectrum kind of opens up, maybe that's a possibility. And I think that's being considered because those are the use cases that are coming up. And if you're opening up new spectrum, you need to take that into consideration.
Yeah. Okay.
All right. So continuing on that, so the third use case was iPhones. So they have these iPhones and they want to run over-the-top voice communication using these iPhones all over the site. Right? So again, pervasive connectivity across 261 football fields. They are using MicroSlicing for the voice communication, so they can make sure that that has the level of guaranteed bitrate and latency as required for that voice application. And then overall, sorry, please.
Is that telephone voice service or is it voice over IP?
Over the top. So
it is over. Yeah. Okay.
It is a data network.
Okay.
In all these examples, it is purely a data network. The voice conversation comes into play in neutral host, and I'll kind of talk about that on the path forward.
Oh, perfect.
Right?
Okay.
Yeah,
awesome.
we will talk about that. Yeah. But all of the examples that I'm talking about and all the deployments we have so far, except for some trials, they're all over-the-top voice applications or video applications. Yeah. All right. And so they have been able to provide pervasive connectivity across this big area, has seen significant improved operations, and more importantly, this is coming from their business decision maker who made the decision to invest in this new technology from their side. They are expecting just from that one use case of site safety inspection, switching over to a more automated way using iPads, they're expecting $1 million savings in just the first year. So from their perspective, investing in a private wireless network with 10 access points for this first site was a no-brainer. And they are already starting to make case for additional deployments in their other refineries. So
how much of it that's covered approximately? How much of it covered that oil refinery approximately? All that area or?
Yeah, the entire area.
10 APs, all that area?
Yeah, exactly. Yeah, yeah. And that's around 0.54 square miles. Yeah.
Okay, all right, cool.
Yeah. And just some data that we make available to our customers and we look at just from a overall performance perspective, the overall device attach and success per, so it's 10 outdoor APs, 261 football fields. The attach success rate is very, very good. And what we've also started to do in the product now is measure what we call as a device experience, right? So we are actually looking at all the factors that potentially can affect a cellular device as it connects to a private network. We correlate all of that information on a per device basis. We aggregate it for a site, and then we aggregate it for the entire network. And we provide that view in the orchestrator, which Prince and I will demonstrate to you in just a little bit. But this is just a snapshot of what the device experience has been for the last 1 week for that specific customer in this large refinery across their entire 261 football fields. I love saying that. All right, manufacturing automation. I can say the name here. We do have a white paper with Del Conca. So this is a Italian tile manufacturer, right? They have multiple sites, manufacturing sites here in the US. For one of their sites at this time, they wanted to provide connectivity. And the driving factor here was they had AGVs that move around, maybe not high speed, but they do move around at reasonable speed across the manufacturing floor. They have these forklifts with computers, again, which move around at a reasonable speed, and then just associates connected worker use case with ruggedized Zebra tablets, right? So they have all of these use cases, and they were having service disruption because at any point, these things that are moving around autonomously loses connection for safety. They basically have to shut down everything. So they have been looking at an alternative. They found one in the form of a Celona private 4G network, and they have actually deployed this across their 30-acre site. Here it's a combination of indoor and outdoor. So you have around, I believe, 8 indoor access points here, and then 4 outdoor access points covering this area. Overall, it's probably a quarter of the number of access points that they would have done with a Wi-Fi system. And then obviously the overall handover performance has been significantly better and has resulted in more efficient and improved productivity from the operations of the manufacturing floor is concerned. And then overall, having fewer APs obviously leads to better CapEx and OpEx for them.
On that topic, it's hard to have the conversation about comparing anything to Wi-Fi without also having a conversation about comparing cost to Wi-Fi.
Yeah.
Are these 3x, 4x, 10x the cost of an enterprise AP?
So great point, right? And Rajiv, our CEO, and I, he also comes from a product background, so we discuss this a lot. And we're like, the way we have priced our solution, so obviously on a per AP basis, that's not the right comparison.
Right, of course.
Right?
Yeah.
The overall total cost of ownership of deploying the product from a 4G perspective, for indoors, we are comparable to Wi-Fi, right? For outdoors, it's not even a comparison because the coverage just doesn't make sense because Wi-Fi can't cover the area that we can. From a 5G perspective, it's probably around 20-25% premium on Wi-Fi. But overall, if you look at the total cost of ownership, we have kept our pricing comparable to Wi-Fi from a per square footage ownership
All in
perspective.
total cost
Exactly.
of ownership. Gotcha.
Quick question, on your outside deployments, are they using directional antennas and are you using cellular sectorization?
We are using directional antennas, yes, for the outdoor AP.
Yeah, okay.
They do have directional antennas attached.
And is it sectorized or is it sector as well?
Yeah.
Okay.
So each outdoor
But maybe
LG,
just-
yeah, go for it, Mehmet, please.
Yeah. I mean, great question. As Puneet said, we have the capability to sectorize, but in some deployments, omni antennas make sense. So we have deployments with omni antennas as well. So it depends on the deployment scenario, I would say.
Okay, thank you.
In warehousing specifically, are you seeing more clients adding these radios to their devices? Where I feel like the warehouse is usually kind of a millennium or two behind where the rest of the world lives.
Great point. And we are seeing a transition, right? We are seeing a transition. And I think the big driver for this has been the likes of Honeywell, the likes of Zebra, especially Zebra, because the kind of verticals that we are targeting, we're seeing that Zebra is kind of the 800-pound gorilla in all of these places, right? They are there everywhere. So in the last 6 to 9 months, all of their products that have come out, and the more that are going to come out the next 6 to 9 months, they will all have inbuilt private 4G, private 5G support, right, in them. Not just for CBRS, but private wireless bands around the world, N77, N78, N79. So they have seen that this particular vertical, the industrialized verticals, are moving towards a private wireless solution, and hence they are headed in that direction. And we see that even in oil and gas, right? Interestingly, it was a surprise to me, but in oil and gas and construction, there's a lot of Apple tablets being used quite a lot. And again, Apple tablets adopted CBRS from 3 years ago with 4G, and we are expecting that in the future, they will also have support for CBRS 5G and other bands around the world as well. So yeah, the device adoption is kind of on the rise, and our success is closely tied to that. And I will talk about how we are trying to navigate that with our device certification program. So I'll speak to that in just a little bit.
Perfect. Thank you.
I have another question, if I may.
Yes, please.
These are great deployments. They're obviously away from people. What kind of bandwidth have they been able to acquire in the CBRS band?
The overall CBRS band. So I think, Mehmet, you can probably answer that specifically because you've been doing a lot of the RF designs. But do you want to answer that?
Of course. Yeah, again, great question. In most of these deployments, we see 100 megahertz or more, right? Of course, the CBRS goes up to 150. And many places we get 150, but in almost all the places we see 100 megahertz or more available. And I mean, as you mentioned, these deployments are typically not in very dense urban regions, right, in the middle of city and so forth. So in these industrial deployments, yeah, typically we get 100 or more.
That's fantastic. So you're probably using a 1 in 3 frequency reuse plan. So each of those cells would have about 30 megahertz of spectrum.
Yeah, I mean, typically, honestly, we end up with 40 megahertz per AP, right?
Yeah.
So we can do 1 in 3, and we typically have 120.
Yeah.
But in certain cases, we may go to 2 channels with 80 megahertz because each AP is again capable of 40 megahertz.
Yeah, that's fantastic.
Yeah, just another view from the data. As I said, they have use cases where things are moving around. The overall handover experience has been good. And again, this is validated by what our new device experience feature is also telling us. And this is obviously, we validate this data with the actual subjective input from customers as well. So it's all adding up. All right. Moving on to my favorite. We don't see this level of high-speed mobility in all use cases, but this has been a very interesting journey for us. So this is, again, warehouse automation. We are seeing more of this. Bots, autonomous bots, moving around at extremely high speeds. This is 30 miles per hour plus. So those are the bots that you see, and they're typically deployed in these steel cage structures. And this particular one, I think, has 14 levels. So it's a metal cage. Again, not a very RF-friendly environment. And then that speed mobility makes it very, very challenging. And the way this particular robotics vendor operates, they actually take, because they don't expect the existing network within a warehouse to support this kind of complex and advanced use case. So they actually bring their own network to the party. So when they go into a retail store or they go into a distribution store or a warehouse, they actually bring in their own network. And so far, obviously, they have been using Wi-Fi with their deployments, and they have had challenges because you need a very, very dense Wi-Fi network to be able to support this. And then even with that, this kind of handover and mobility is hard to sustain. And the problem with that is the moment you have a disconnect beyond a certain period of time, for safety reason, the bots have to stall, not just one bot, all the bots, because they're all kind of coordinating with each other. And then you have to manually wrangle it up and reset it. So that kind of just brings down the operation and doesn't really scale. And hence, they have been on the lookout for an alternative. We have been working with this vendor for the last 12 to 18 months, kind of fine-tuning what the devices can do. Because even the devices, for example, in this case, we're using a Sierra gateway. They're not designed for that kind of mobility and that kind of high-speed mobility support. So there have been a lot of work that's been done by the device vendor, by the network vendor, and the application vendor to create a solution that can actually be used and deployed in real warehouse deployments. So here is an example of that. There are 150 robots that are actually moving around at 30 miles per hour in this 14-level steel cage, covering around 600,000 square feet. And overall, in comparison to Wi-Fi, what they had previously, it's about a 10 times reduction in the number of APs that you have had. And these are indoor APs that we're talking about. And then overall, 90% reduction in downtime due to the mobility support that Cellular has built in, right? And here is some data which I thought was actually pretty cool as I was digging through it the other day. There are around 60,000 handovers per day at this specific distribution center across 150 active bots. The overall handover attempts and success percentage is always above the 98%, which meets their criteria. And also, even when there is a failure, the time to recover is below what their threshold is, so the system can still continue to operate. The handover times and the attach times are well within the limits of what they would need for successful operation of this application. And I thought that was a pretty cool chart. I don't know how useful it is, but I thought it was pretty cool to see all the different access points that you have deployed on the floor and this is on a single day, all the handovers that are happening between each of those access points.
Is that from your interface, like from your orchestrator? Yeah, or is it somebody created this?
So this is from our, I would say, beta orchestrator, the internal one. Some of this data is in the orchestrator, and I'll show you.
Okay.
But some of these other things because again, from a product management perspective, I don't want to overwhelm them. So we are using this data internally.
Okay.
And then as we find things useful for our support team, our field, we basically say this is ready to go. So it's basically going through a baking period in our, I would say, a beta orchestrator. And yeah, but very soon you'll actually see some of this.
I'm really interested. Where did you actually put the APs in that? Because I've actually done a Wi-Fi design for practically the same system.
Yeah.
A slightly different one, and we had to put literally the APs down every row in this cage environment. I'm just wondering, where do you put them? Do you put them inside the cages, or whether it's off outside beaming in?
Yeah. So, Mehmet, do you have the details of exactly where the APs are placed in this particular setup?
Yeah.
Okay, please go ahead.
Yeah. I mean, we end up placing the APs on the ceiling, actually, on the very top ceiling, and to our great surprise, I mean, the signals bounce and propagate.
Yeah.
To the different levels. Now there are some details. There are a place where these bots go on kind of to different levels, like the elevator region, and there we realized to optimize it further, we can put the APs on the side, on both sides, to shoot towards that region with the metal levels. It may not make sense to everyone listening, but I'm sure you understand what I mean.
Yeah. No, I do.
So in this case, interestingly, the metal cage actually is working in our favor, where the signal is actually bouncing around and helping with the propagation. And you've seen that even when there's water bodies and other things, right? The signal just propagates significantly.
Yeah, that's what I was wondering. Yeah. Interesting. Thank you.
Oh, lovely. Good question. And again, this is, I just have to show off our new beta feature. So this is another plug. So this is the device experience for that specific site. And this specific one is already in the orchestrator. So again, I'll show this to you later. On this.
Your average latency for your roams was around 110 milliseconds. It said. What were the outliers? What was the max? What was the min on those? Do you recall?
I don't know if I have it on the top of my head, but definitely, probably in the breakout session, I'll be able to. I can go into the
seconds or like one or two that were like way out there.
There are one or two anomalies which probably go into half or 1 second duration. You probably have that, but this is what
by and large.
Typically see. Yes.
Yeah.
I mean, have you guys kind of seen these kind of extreme use cases? Because I thought this was a pretty cool one, but I don't know if you guys have had experience with this.
I haven't had direct experience with this, but I've had a lot of experience trying to get robots to work on Wi-Fi.
Okay.
And I've said, no, we should probably do this on cellular.
Okay.
So-
Okay. So this you kind of it aligns with what you have been thinking about as well.
Robots are stunningly bad Wi-Fi clients at least.
Yeah.
One of the things that we see is it's a hard problem to solve in a lot of cases because they put the radio on the robot inside a giant metal box that sits underneath whatever the robot's carrying.
Yeah.
Yeah, where they place the antenna on the robot, so often really dumb places.
It almost doesn't matter what the infrastructure is because you've just buried that antenna in a bunch of metal.
That's right.
Well, not only that, but if you talk to the robot vendors and go, well, do you support RK and V? And they'll be like, what? So, yeah.
Yeah, makes sense.
And with this, they don't need to.
No, I'm glad this resonates with what your experience has been as well. So thanks for that feedback. All right, moving along. So key learnings. Again, some of this might be preaching to the choir, but I thought this was quite interesting to kind of think about the last 3 years, the kind of deployments we've had, and what we have learned from that, right? So needless to say, the big pain point in industrial environments is outdoor. Now, initially, when I was doing my 3-year forecast with our CFO, and I would say, okay, I'm expecting 60% outdoor and 40% indoor, and this is what the forecast is going to look like. It's all kind of fallen by the wayside, right? In the outdoor use case, at least at this point, kind of are a beachhead use case for a lot of the deployments. They are using it in parking lots, in some of the examples that I just showed, and it becomes a very, very easy sell for a business decision maker to say, okay, this actually makes sense. There's a business outcome directly associated with it. Let's go. Even if it's a new technology, I'm ready to invest in it, right? So we are seeing that quite a bit. And what that means is we have cases where you have outdoor private cellular, private wireless, and indoor Wi-Fi. And the same device, and this is a case of a big retailer where folks move in and out of the store and they use the parking lot connectivity to actually do pickup and deliveries. And then as they come in, they use the same devices for scanning and other activities within the store. So inside, it's connecting to Wi-Fi. Outside, it's connecting to a private LTE network. So one of the things that we have been working through, and Mehmet has been kind of driving the charge here, is how do you make sure that the overall device experience between Wi-Fi and LTE as the device transitions between those two technologies is seamless? And what can we do? And what can we do from a network side? What can we do? And how can we influence the roadmaps of some of the device manufacturers to kind of continue to improve that transition between the two radio technologies? So that's something that's work in progress for us. Number 2 here is, again, what we're seeing is where they're deploying private wireless, the use cases are always mission critical. It's not me connecting on my laptop to a network. It's always a robot, a connected worker use case, and any downtime is going to affect the bottom line, right? And hence the SLAs that we have had to sign up for have been very, 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 very high in comparison to what a Wi-Fi vendor might need to, particularly for these mission critical use cases. And then you tie that to the spectrum access system question, and I think we talked about that briefly earlier. With CBRS, as you are all aware, the spectrum management is handled by a central database called Spectrum Access System. You have vendors like Google, Federated, and others who are actually offering that as a service. We work with both of them. And the idea here is that our learning has been that, is it a curse or a blessing? I don't think there's a right answer here. I think depending on the situation, it's great to have a centralized data system, then centralized database that can automate and make it all dynamic as to what spectrum is available at what location. But the fact that you're sharing it with incumbents, you're sharing with PAL license owners, and to your question, Avril, does that then make it palatable for some of these mission critical use cases? And in dense urban environments, sometimes we have seen that the spectrum available might be challenging, right? And what you have to do in that scenario, and what we have had to do, is build a lot of intelligence into the system. Our roadmap, at least for the last year, first 6 months, we were doing a lot of work on our SON algorithm and our domain proxy, which basically talks to SAS, in order to add intelligence so we can automatically recover as and when there are any changes in the available spectrum. And how do you do it dynamically? How do you do it by providing minimal downtime for your network? So a lot of effort and time actually went in, where initially we thought hey, everything would be managed by Spectrum Access System. They'll tell us what's available and we'll be good to go. But we've had to do a lot of work on our end, and other vendors are doing that as well, to make sure that we can live with the dynamic nature that SaaS presents.
But you're only going to give visibility into your stuff. So
Yes. Yeah, we do. They tell us what's available, right? And then if the same, for example, if an incumbent comes up and says something is taken away, they let you know. And now you have the ability in a certain time period to then find a way to dynamically switch to another channel.
But if you're doing that and my next door neighbor is using a competitor's solution that is phoning into a different SaaS, how do you keep track of the changes that SaaS is delivering to that person? Because it's not one big service, is it?
It's not. So each of them is an independent service.
Yeah.
But at the end of the day, they are kind of trying to keep it as a single source of truth as much as possible. They're not, like, for example, Google and Federated, they're not talking to each other all the time, but every night they basically synchronize all the data as to who's using what, and they kind of manage that across between the different SaaS vendors. So they try to keep it to a single source of truth as much as possible. And given where the market is, overnight synchronization is fine at this time, depending on the density of the network.
And of course that's the problem, right? Is that once this explodes, it's going to be far more problematic. And so I guess to that end, do you have any comment on the number of Celona networks that are brought up on GAA versus PAL?
So today, I would say pretty much 99% of the networks are all on GAA.
Really?
Right? Yeah,
Okay.
all of them. Right?
Oh, geez.
There are a few networks where we have been working with our service provider partners and our SI partners, where we are exploring, especially areas where there's not enough spectrum, or
Bingo.
in that case, we are working with using PAL and trying to kind of make sure that the mission critical nature of the use case is protected. So yes, so there are, but at this point, most of the deployments are GAA.
And you feel you can do critical network infrastructure services on GAA indefinitely?
Not indefinitely. Not indefinitely for sure. I think.
How long of a problem do we?
I think that's a good question, and it's a good problem to have. So I would say that for the next 12, I mean, Mehmet, please feel free to jump in here. In my opinion, as I'm seeing kind of the ramp up happening for private wireless networks in the US, I'm expecting 12 to 18 months. I think we are in a decent shape, but we expect that beyond that, we would have to start exploring either licensed spectrum, PAL, and then potentially, as Mehmet mentioned, as other spectrum opens up, 3.1 to 3.4, those are the avenues that become available to us. So from a spectrum strategy perspective, which Mehmet and I are kind of helping drive, we are having conversations with exploring licensed spectrum, exploring PAL, as well as exploring the future spectrum that potentially becomes available.
Thank you.
Can we go back to the SaaS for a second and kind of related? Any plans for SaaS redundancy?
Yes.
I think everybody remembers I think it was Federated's outage.
Oh, yes.
And it took down, network
absolutely.
that we're.
So I think that one of the things that we are doing is we are working with both the Google and Federated, right? And from our perspective, we have building a system that kind of has a view of both the systems while kind of living within the limitations of what the regulations kind of provide us. We are trying to build in as much redundancy as possible that allows us to kind of provide, if there is an outage on one system, how can we seamlessly kind of move over to another system and do that in a dynamic fashion? And again, we always thought, and that's one of the learnings, right? You always thought this is a critical piece of the architecture and it's solid, but both with Google and Federated, we have seen that there have been, there's always, it's software after all. There are challenges. And then whenever there's an outage, as a vendor, we now need to kind of make sure our system is robust to handle any of these vagaries that might play out in the real world. Mehmet, anything you want to add?
Yeah. And I mean, I also want to kind of emphasize that the question for us has been how seamless we can make that transition. And actually, we made great enhancement in that. I think we are pretty good in terms of how seamless we make it for the end customer so that they don't notice, if there is any outage with one SaaS vendor in terms of how quickly we switch to the other. So we have done some kind of innovative work in there as well.
And yeah, I'm sure Mehmet is busy filing patents for that. All right. Going on, so as I said earlier, and this was the question that was posted earlier, we are seeing an influx of either existing Wi-Fi engineers or network engineers ramping up on cellular. I have seen that transition happen, and I'm seeing in our enterprise teams, cellular engineers being injected into the network infrastructure teams. So what that means is the kind of questions I get as to what they want to see and do in the orchestrator has been evolving. And we started with the approach of, hey, let's abstract all of this detail. Let's call it AP, and let's not really go into the details of TDD and carrier aggregation and all of that stuff, and keep it very, very simple. But that vision was short-lived. And as we are seeing cellular expertise kind of come in, we have had to evolve what our strategy from a product roadmap direction is. So both Prince and I have been working with our design team and our engineering team to kind of open up the Pandora's box to say, and then kind of give them the advanced configurations that some of the audiences are asking for. So you will see that in the product when I go into that in just a little bit.
Right. So I guess what is the strategy if it's focused on enterprise?
Starting to get a little bit of cellular expertise. Are you still using enterprise-friendly terminology and kind of giving us rope but not enough to hang ourselves?
We're trying to. I'm getting pulled in both directions, and I'm trying to figure out what the right balance is, honestly. So you will see that when you talk about TDD, we just don't say 3D1U. We say uplink heavy patterns, downlink heavy patterns. So we're trying to kind of hit the right balance. And obviously, the feedback will come from users like yourself, who will then inform me, hey, are we going too much on the other extreme, right? So we'll probably work together to kind of find the right balance. But I'm letting our customers kind of drive some of that decision for us.
Yeah, that's incredibly tough because it's the standards-based terminology. You can look up, you can get a really good understanding of what it does and what it doesn't do, but it's also not terminology that the network engineers are familiar with.
Exactly. You don't want to overwhelm them in the first place. So that's another thing. That's where user experience kind of comes into play, right? We have a design team who's constantly thinking about how do you make these things even available. Like for the most part, 90% of the time, you probably don't even need those configurations because the system is doing it for you. But for those people who need it, just like you have it on your app, the advanced settings, you probably kind of create that tier where, okay, if you do need to play around with these advanced settings, be aware that that has implications on the network performance, but looks like you know what you're doing, go ahead and do that, right? So, so that's where I think the user experience piece really comes into play. Mehmet?
Very good point. I just wanted to share, it's kind of amusing for me to see, we have this very senior, seasoned Wi-Fi engineers in our company, right, who worked on Wi-Fi systems for 20 years. And I start seeing them to use more and more of the 3GPP terminology. Roaming becomes handovers, and, they start talking about UPF, AMF, SMF. So it's funny to see that evolution even as a company for ourselves. We're always trying to strike that balance.
All right, and I think this came up earlier as well from a device perspective. I don't think there's any substitute for us. I know we're a small company, but having a comprehensive device certification program is very important for our success. So we've basically taken the bull by the horn from the very beginning and said, you know what? We have to make sure that at least the devices that we are seeing most often in these industrial verticals, we will take upon ourselves to certify them. And it's not just that, okay, you go look at their specs and say, yes, they support this band, they support the 3GP. No, you actually need to go through a full detailed interoperability test plan, make sure it connects to the network, adheres to the performance standards that we are signing up for our customers, works with MicroSlicing if it's relevant, works with supernetting if it's relevant, and I'll talk about what that is. So going through a full plan, and it's fairly systematic. Our QA team kind of runs with it. And then we also make that available to our device partners so they can actually go and self-certify as they release new devices. So a lot of our device partners that I'll talk about actually have a Celona network deployed either in their lab or their EBCs, which they're then using to certify and self-certify some of these devices as well. So that's a very, very important part of what we believe is going to be the reason for the success of private wireless network. And then, again, you asked the question earlier, so this is a plug for that. Device availability. that is what is spurring adoption in the uncarpeted industrial enterprises. So as you're seeing these ruggedized devices start to show up with cellular capabilities built in, you're seeing an upswing in enterprises now willing to coming and trying this out. Otherwise, they're like, okay, our device refresh cycle is 3 years out. We will play around with it now, but the real deployment will happen 3 years. But that was 3 years ago. And now that these devices are showing up, the device refresh cycle that will happen now will all support cellular natively in a lot of these cases. And hence, that was going to be a big trigger for what we believe is a bit of a hockey stick curve for the overall market in industrial and uncarpeted enterprises. And then finally, it's still interesting that the ease of bring up and the Wi-Fi-like operational model from Celona's perspective, I think is still a key differentiator for us. And hopefully in all the activities that we'll do today, we'll be able to showcase that to you, that you can actually, and last year when JR and Kevin did that, he probably showed that how you can actually bring up a private 4G and a 5G network. It's not as ominous as it's made out to be. And that ease of bring up and the operational model that we have been able to put together and deliver to our enterprises is what is differentiating us from this Me Too private wireless market segment, because everybody, including my grandmom, is doing private wireless now, right? So it's so in that space, it's extremely important as to what your key differentiator is and what you're delivering to your enterprise customers in this case. Want to share?
So I suspect, and maybe you want to confirm this, that it becomes much more critical to do a site plan for deployment of cellular technologies. I mean, it's critical enough for Wi-Fi, but it's even more critical, right, for 5G network. Would you agree with that?
Absolutely.
Your deployment?
Great segue, though. So, yeah, I mean, absolutely, Avril. And the reason I moved to the next slide is that's from those learnings, how has the product hardened, right? So obviously, we have our teams, our SEs, our field engineers who work closely with our customers to help with the RF design. We have an RF design team that actually helps with especially these outdoor deployments, which can get very, very complex. But then taking all of that in and building it into the orchestrator, because end of the day, from a customer's perspective, from a user's perspective, you need to program the orchestrator to build that network out for you. So I'll show you an example of how some of those RF design, you'll do the RF design in the IB Wave or Google Planner. But once you do that, what do you do with that information? How do you then bring it back into the orchestrator, because that is your window into programming the network. So yes, absolutely. That becomes very, very critical, and a lot of time and effort has been spent to trying and making that easier. Now that we go to outside of US, Mehmet and I are figuring out, okay, if Google Planner is not going to work there, what other planning tool can we use, and how does that integrate with Celona's orchestrator and make it as seamless as possible? So absolutely, that becomes very, very critical. And I won't go through each of them because I'll jump into the product and show some of this. But overall, I think with all those learnings, I think a lot of features have been added into the product to harden it. To Avril's point, the channel planning, which is now a critical aspect of your cellular network bring up, is actually built into the orchestrator that our field can use and our customers can use. Again, Wi-Fi has made this commonplace, but one-click inventory onboarding and zero-touch provisioning, which is now commonplace with Wi-Fi and other network infrastructure systems. That's something that we have built in from day one. The device experience analytics, something that I'm very excited about because it gives you that one view that tells you how is your overall network doing. And if it's all good, then you don't really need to bother. But if you do see a dip, you can then drill down and really understand what the problem might be. So we've started down that path, and I'm excited to actually show you what that looks like. As I said earlier, we are starting to peel the onion, provide finer-grained control on advanced configuration, more troubleshooting and diagnostic tools, because people want to have these self-service workflows that they can operationalize, especially now that we have partners who are offering this as an MSP, right? As a managed service provider, they're offering this to enterprises who might not have the skill set. And how do our MSP partners actually use the system without Celona engineering, Celona support, and Celona field team being with them to work with them and be high touch? API first platform, again, today you build a cloud-based system, you build a networking infrastructure, you cannot get away without having it available, the data available via APIs. So that's something that was done from day one. I will talk about supernetting. It's a bit of a controversial term, and I'll admit that our field engineers have given me feedback on whether they like the term or not, but I'll speak to what it is, and then we can discuss about the naming of it. PTP, for those who are familiar with cellular, time synchronization is extremely important for access points and radios. They need to be synchronized to microsecond granularity, which your regular NTP servers cannot provide. And hence, you need to have a dedicated system that provides that precision time synchronization between your access points, which then gives them the ability to deliver all the SLAs that I've talked about. So how do we streamline some of that? How do we make those configurations, again, available in the orchestrator? How do we give flexibility for different deployment types? For example, the outdoor access point can get its synchronization from GPS. The indoor access point can also get it from GPS, but it can also get it from an external PTP time server if that is available. Or if you have an indoor and outdoor deployment like you did at Dell Conquer, you can make your outdoor access point as which already has a time sync from the GPS. You can make that the source, and all your indoor can just follow that. So these are all software enhancements that we have made based on our learnings of deploying it over the last 3 years and trying to continue to kind of add value prop and make it reduce the barrier to entry as we have had these learnings and run into them over the last 3 years. High availability edge cluster. So this particular Celona edge can be deployed in a highly available cluster mode. So you can have 3 servers removing a single point of failure. I'll show you how that looks like in the orchestrator. And then going forward, for Wi-Fi engineers in the room, this would be very familiar, but how do you now integrate a cellular core with your NAC servers, right? How do you get these policies that I'm today defining in the orchestrator? How do I get that from a network access control system that the customers already have deployed? So we are starting to kind of build that in so you can get those policies automatically, so the authentication can still happen using the SIM-based authentication in the Celona edge. But then once the authentication is done, the authorization of that can be triggered via Radius with the network access control system. So that's something that's hopefully in the next meeting that we'll have, we'll be able to demonstrate that to you as well.
So you're hinting that you're going to integrate with external NAC solutions that are already in the enterprise.
Yes, exactly. That's the idea. Yeah, because again, we don't want to introduce anything new. The firewalls are there, the NACs are there. We want to make sure we work well with them. So we will basically have the ability to integrate with NAC servers, and we'll use Radius. So that means we could integrate with any of them. Yeah, that's the idea. Yeah.
So are you going to dive more into these things? Because I
will.
A couple of questions about specifically device experience analytics.
Absolutely. I'll actually show it to you, and I think it'll make it more interesting of a conversation. Cool. And the last one is again interesting as you start to see. So the deployments that I showed you were like 10, 20, 15 APs in a site. You probably need best deploy a dedicated edge cluster there and terminate your traffic. But we are also seeing where you have these distributed branch offices where you have 1 AP, 2 APs. Having an edge cluster in every is going to be cost prohibitive. So as we start to kind of enter those markets, we are looking at supporting remote AP. I think it's a common term used in Wi-Fi where you actually do a local traffic breakout on the access point. So part of the data plane can actually be running on these access points. So and then based on the policy, you could break out some application flows locally, and for others, you could terminate all of them on the Celona edge. So that's something that we're already starting to design and develop, and expecting that in the 3 to 6 month roadmap, we should be able to deliver that to our customers and start to make ourselves relevant in that distributed enterprise deployments. So I won't be able to show you that today, but some of the other features I'll jump right in. All right. So what I'm going to demo to you is not this network. That's Prince's forte today. What I'm going to demo, I'm taking the easier route. I'm demonstrating to you our Celona headquarters, which is in Campbell. So we do have a private 4G and a 5G network that we have deployed there. And a lot of us, when we are in the office, you might see Rajiv's iPad as well, if he's in the office. We all use our either a dongle, or if the device natively supports it, we typically connect to those networks when we're in the office. So you might see some activity, given that it's Friday noon. Let's see how much activity we see in the office. And as I'm showing you that network, we can dive into any specific questions that you guys have. All right, so this is what the latest and the greatest orchestrator currently looks like. We are on the landing page of the orchestrator. As I said, this is our HQ network. We use it as a beta network that we try and dog food any new releases that are coming out. We currently have one edge cluster with 3 nodes, so it's a highly available edge cluster. It has currently 2 access points that are up and running. So I'm assuming one is 4G, another one is 5G, but I'll confirm as we go down. Looks like one of them is down for some reason. And currently there are around 12 devices connected. 11 of them are actively sending traffic on the network. And this is the device experience view, right? So at this point, I'm looking at the overall network, and I'm looking at the device experience. And again, any flaws or bugs, I'll get away because it's still being called a beta. But yeah, this is something that we just released to our customers, and we are getting feedback. So here, what we're looking at is the overall device experience the score is good. There were some dips, and that's probably to do with one of the APs that went down. These are all the factors. So when I go and click show evidence, it'll show me all the factors that are currently being considered. So you have the attach success rate, the handover success rate, the time to attach, time to handover, time to recover after a disconnect. So all of these factors are being actually taken in to then create a score at an individual device level, which is then being aggregated at a site and then aggregated for your overall network, right? And as you look at this as a user, I'll see, okay, everything is great. But for example, if you had multiple sites, you would see a ranking of all your poorly performing sites, and you could drill into that. And once you drill into a site, you will basically see a view of that specific site and a device experience score for what we're calling here as the HQ Beta 4G site. And as you go down, you can see who are your worst performing devices. So again, here is fairly good, so you won't really bother. But if you did have a red or a fair, you would drill down into the specific device and then try and understand what might be happening. Oh, this guy did have a dip here. And the biggest contributing factor there was the attach failures. And then you can look at exactly when that happened. So for example, the other day when we were looking at one of the dips, it basically said IP address allocation failure. So effectively what that was translating to was we were having a DHCP outage in the network. And I think it was simulated by our QA engineers. And we actually saw that the system did detect that and was able to actually provide some root cause analysis as well. Now, we are early in the journey of providing detailed root cause analysis. But at this point, we're able to drill down to a specific device, and we're adding additional root cause analysis, and maybe in the future, some kind of a remediation as well, if it's something that is within our network that we can tweak. But going back, sir, you had a question on the device experience itself?
Yeah, it's actually probably a pretty easy one. Is this going to be exposed to the API?
Yes. Okay. Great question.
Not yet.
Great plug.
It's not yet, because I don't think it is anyway, because one of our engineers was just trying to get it out of the API.
So because it's a beta feature, so probably the documentation is not updated.
Okay.
So let me explain to you how the orchestrator is built, right? So everything in the orchestrator is using an API. And the moment that feature becomes available to customers, kind of generally available, those APIs, we expose them to customers as well, the ones that we are using here. So think of orchestrator as just an example of how the API can be used. Now, sometimes when a feature is beta, we might shy away from exposing the APIs because it could change based on the feedback that we get from customers, and then it breaks the customer's implementation. So if it's absolutely needed, we can definitely expose it and people can play around with it. But typically when a feature is in beta, that means it's likely to change. So the API structure might change, and hence it might be a breaking change for you. So we might have not updated the documentation, but everything is available via APIs. It's a question of whether we are ready to expose it to our customers or not.
Yeah, I think that's actually what he was posting. It's not in Swagger Hub yet. So.
Yeah, exactly. All right, so going back to the top here, again, as we start to kind of get into production networks, customers want to consume alerts and they want to consume it programmatically. This is something that they can actually program themselves. So this is the alerts framework that we have just created. It's a webhook-based push notification that's available. And again, these are some of the alerts that are available, and we are constantly adding more. So AP, edge, device, anything to do with the domain proxy and the SaaS anything to do with the CPU alerts, PTP states, which is something that we see quite a bit. So we're constantly adding. So as a user, you can just select all the alerts that you are looking for. What is your consumption mechanism? Do you want to do it via Slack? A lot of people actually, interestingly, are doing over Slack now. But if you have other ITSM systems, like ServiceNow, that you can provide the URL for, so our systems will basically push these alerts to your systems, and then it'll basically queue up in your ITSM system as long as you can consume webhooks, which most systems consume today. So this is actually built into the product as well. There's the whole events for site APIs that one can consume either here or via APIs. Jumping into the site, and Prince will kind of go into what a site creation workflow looks like. So I don't want to steal that thunder. But just looking at a specific site here and going into Avril's question earlier. So as I look at the site, and we looked at the health of the site, but if I look at the config for the site, this is what the site information looks like. So it is currently being served by that HQ beta cluster, and I'll jump into that in just a minute. There are multiple PTP time sync servers that have been configured here, right? So you have the ability to configure external PTP servers if that's available to in the network. Or as I said earlier, you could use one of the APs as the source, as long as that one AP, outdoor or indoor, has a GPS signal coming to it. And this is where kind of the site planner tool comes into play. So we have both indoor channel planner and an outdoor channel planner available in the product. Again, for Wi-Fi engineers, this might be something that you've probably done in the Wi-Fi tools. But what happens here is you'll ingest a floor plan. As a user, you'll be providing us a floor plan. You will provide us an IB Wave input. So today it integrates with IB Wave. We're talking to Hamina and others to see how we can kind of do a cloud-to-cloud integration and ingest some of that data. But for now, we ingest IB Wave data. Based on the IB Wave data and the floor plan, the APs automatically get placed in their locations. So you don't have to really place the APs. That happens automatically. And with that information, you basically feed that to our SON algorithm. That put together with what is available from the SAS, from spectrum and power perspective, all of those inputs then basically determine what the RF plan for that particular site deployment looks like. So once deployment is up and running, you can basically see what the RSRP signal strength map looks like, what does the signal to noise ratio heat map look like for your entire site. And we do the same for outdoor channel planner, where, again, this is an indoor setup, so we don't have an outdoor plan. But if you did have one, you could actually take your Google plan, export it to a CSV, and ingest it here, and then automatically that put together with what's available from SAS dynamically, the RF plan for that particular site will get determined.
Could you go back to the heat map for a second?
Sorry? Yeah, sure.
Am I missing a legend? What the colors mean?
Yeah, I mean, yeah, that feedback has gone in. Yeah, absolutely. And right now, you basically have to hover over it and tell you what it is. But yeah, that particular piece is some feedback that's gone in. Yeah.
So is it displaying the heat map based on what? Like, is it grabbing that information from clients that are connected?
No, not yet. So not yet. So today, it's not grabbing it from the clients. What it's doing right now is based on the IB Wave input that's been provided, we get a path loss propagation model for that particular floor. And then we know what the power levels for each of the APs are and what channels they're using. So based on that, it's actually creating that dynamically. But it's not necessarily using UE measurement reports yet.
Now, I'm not familiar with IB Wave. I mean, does IB Wave have probably, I'm assuming, draws walls or exactly objects? So it considers that too?
Absolutely. Yeah, absolutely. Yeah.
Is it actually dynamic? Because isn't one of those radios down?
Sorry?
Wasn't one of those radios down? You had two up and one down, and it looks like it's still showing.
It's showing the APs here, but I think the state of it is not probably updated yet. Yeah.
When are you expecting Hamina support to be in this?
We are in conversation. I mean, I wouldn't be able to give you a date right now, but we have looked at the APIs and have been talking to, I think, Husi. And I'm expecting that over the next few months, we'll probably start to make some progress on that. Thing is, a lot of our customers and internally, we still use IB Wave. So that's what we have kind of focused on at this point. But looking at the APIs, it looks like a fairly good value prop for us to integrate.
Yeah,
and it
yeah.
We make for a strong story.
And I think from our perspective, a lot of the wireless community, although there certainly are people that use IBWave, a lot of us use Ekahau or Hamina. So if this is if we're a target audience, using the tools that we already use, I think would be a good
absolutely.
step.
Just that IBWave has was the first one that was available, that was being used a lot.
Yeah, they already
was something new, so we are starting to kind of work with them. So I think you should see that in the next 3 to 6 months.
Yeah, when you guys launched, they were the only one with cellular planning.
Yeah, exactly. Yeah. All right, so jumping into a specific AP here. So this is an indoor access point. So right here, AP12. It's a two sectors here, inbuilt and with inbuilt internal antennas. It's on the latest software 2304 that we just released. And as you see, go down here, we started to kind of expose some of these parameters. Right now, again, waiting for feedback on customers, but the TDD, time division duplex, right? And there's config 1, config 2, config 0. But we have tried to kind of be as descriptive as possible. So in this particular case, it's an uplink heavy pattern that has been selected for this access point. And then with this advanced configuration, you can choose to enable, disable carrier aggregation. You could even change the power levels. Obviously, the max power level is going to be set by what SAS tells you, but within that, you can obviously reduce the power level. For example, Prince, for this access point, he has reduced the power level so that it meets the safety requirements for this room, and we all don't have to run away. So that's some of the advanced RAN configurations that is being added to the product. Along those lines, there's this concept of wireless configuration templates. So to make it easier so that you don't have to go configure each AP, we are creating templates for the site where if it's a warehouse template, you could say, okay, for a warehouse with high-speed mobility, these are the handover parameters that I want to be setting. You could create that and then push it down to your entire site. So this is the template configuration that we have started to add. It includes things like QAM, TDD, and then in the future, I do have a mock-up for that. Let me see if I can here. So the template will start to include additional things like the max device load per profile, the CQI information, some of these things even I'm trying to keep up, the HARC. So all of these advanced configuration will be available as a template, which you can set for your site and push down. As I said, something like this would be available for advanced users, right? And potentially you could use RBAC to manage who has access to this and who doesn't.
Are you showing any quality of service settings at this time?
So from a MicroSlice perspective, yes.
From a slice perspective, yes. Nothing beneath that.
Nothing beneath that.
Okay,
no.
good. Yeah. Okay.
But maybe we can discuss in the session what specifically you're asking for. Yeah.
That's fine.
All right. So maybe if I go back into the site, as I said earlier, if I go into the 4G site, let's take a look at the high availability cluster because that has some very unique capabilities. So when you look at the cluster, this particular cluster in the office has 3 nodes. It's currently, the network name is set to Celona. So this is an interesting feature where, more of a vanity feature, where customers can actually set this to their own network name and devices, some of the devices will actually pick it up. So they'll see that it's actually connected to their own network. A very simple feature that was added so that allows them to edit it. For non-US deployments, people can change the PLMN ID to a different one than 315010. These are all the monitoring details on an edge cluster basis that we are tracking. Who are the top talkers? How many active nodes do you actually have? What is the overall throughput? These are the 3 nodes, physical nodes that are currently running in the headquarters and managing the network. They are, you see 1 leader and 2 followers, but effectively it's an active setup. So all 3 of them actually have active data plane services running on it. And the UEs are basically getting load balanced across all 3 of them. So it's not just providing high availability, but also allowing you to scale as you add additional nodes. And again, it's a Kubernetes-based cluster, and all the core services, the spectrum management, the IP stack, all of that is running as microservices within this self-managed Kubernetes.
And are these all the same sized appliances, meaning they all have the same capacity? Can you mix capacities? What does that look like?
You could, but typically we have two options available. We have an express option and an enterprise option. So typically, a cluster will have a bunch of express nodes or a bunch of enterprise nodes.
Okay.
The express nodes typically can support up to 40 access points, and then the enterprise node, which is what's running here behind me, can support up to 100 access points. But typically, you will not see
mixed.
Yeah.
So you're going to get all enterprise or all. Okay.
And then this goes into a little bit of the IP domain piece, where again, this is looks like a very simple piece, but maybe I'll spend a little bit of time on this one. So typically, the cellular network is a L3 network, right? And when you deploy a cellular network, typically all the cellular devices that are getting added to the network, they are NATed. So the enterprise does not really have visibility into the devices that are being added to the network. So that's what the internal IP domain is. So when we create an internal IP domain, the edge acts as the source of IP address for the devices, and the devices' IP addresses themselves are not visible from the rest of the enterprise infrastructure. Now, that's great for a demo, but in a real-world environment, you need an external IP domain, which allows you to configure the specific DHCP server that you actually want to use for your devices that are associated with that IP domain, the VLAN tagging that you want to associate with all the traffic originating from those devices, and what VLAN do you actually forward that traffic on. And this is what ties into what I was describing earlier with regards to the segmentation of the traffic, right? Particularly from a security perspective and from a QoS perspective.
Is IP domain, is that a cellular term?
No, it's a Celona, kind of more of a network. So IP domain, IP subnets, that's what it kind of translates to. And here we have different IP domains that we have created. So all the employees are on the external employee IP domain. So we are on a very, very specific VLAN. So from a network and a security perspective, we can get very, very specific treatment, and our firewall policies can be also defined appropriately there. And then all the IP addresses that are then given out to the cellular devices are actually coming from the enterprise's DHCP infrastructure, which means that the firewalls can actually see which cellular devices are on the network, what they're doing, so they can now continue to apply the policies as they would for any other device.
And you can talk to them directly because they're no longer behind a NAT boundary.
Exactly. Yeah. You can talk to them directly. Traffic can originate from the server side and then reach out to the device. It's all reachable and visible. So both from a networking and a security perspective, this is what enterprises need. And in most private cellular systems, because they were built for the macro, this is not available.
How are you dropping these devices into different VLANs?
Sorry, what is the question?
When a device connects, how do I drop it into one VLAN or another?
Yeah, so the way it works is, so within the Celona edge, for each of these IP domains, we end up creating a sub-interface. We end up creating a sub-interface for each of the VLANs. So, and internally, when the traffic originates from that device, it's terminating on the Celona edge. Right. And then on that interface is what we end up kind of VLAN. We basically apply the policy on the Celona edge and then forward it on that VLAN.
But from the client side, am I connecting to a different SSID? Is that the right terminology? Or is it something on the inside that says, okay, you're an employee client?
So from a device perspective, all you have is a SIM.
Yep.
And so your identifier on the network is your ICC ID, which is the identifier for the SIM, and then IMEI, which is the identifier for the device itself. So that combination is what tells us what the device is. Now, today, these policies are being defined in the orchestrator, right? But that policy can potentially come from NAC as well, where when you talk to the NAC can tell you which device group does this combination belong to, and based on that, the appropriate appropriate VLAN can get then implemented. Yep, so that's what we intend to do with NAC. Today, this is being configured the policy is being configured within the orchestrator.
So question that came in back to the clusters is how many APs can like the largest clusters support?
So typically, as I said, let's talk about an express node.
Yeah.
Right? An express node can support 40. So if you're building a 3-node HA cluster, you would probably not want to do more than 80 access points on that. So that even if one goes away, you're good to go, right? So that's how you think about it. And then for an enterprise cluster, each of them can support 100. So you'll probably build a 3-node cluster to support 200 access points. But as I said, the coverage characteristics of the cellular is such that you don't have, at least so far, the sites are not as that dense, right? Typically, they are much smaller size.
And you can still have multiple clusters if you would need to grow beyond that.
Yeah.
Can your clusters go beyond 3 members?
Yeah.
Okay.
Yeah. You can scale it out horizontally as well.
Okay.
You need a minimum of 3 for HA, and then you can scale it out beyond that.
Okay.
All right. So just I won't go into the micro-slicing configuration, and I know Avril had a question, so Avril, I'll please hold that thought for a little bit. We'll come back and actually show a demo, and hopefully, Prince, it's all lining up nicely for that. But I won't go into the QoS and application identification engine, but yeah, diagnostic tools, right? So as we again look at MSPs and enterprises starting to use this and make it a self-service tool, some of these tools previously were being used by our support team out of band, out of the orchestrator, being able to take logs, being able to run packet capture. So all of this was being done by our support team. And now that we are starting to kind of make it more self-service, we are opening it up to our customers and our partners as well. So they can basically take logs on the 5G core, reboot the AP and test connectivity, check bootstrap information. Everything that we have found useful internally, we're basically making it available to our customers so they can troubleshoot and be self-service when it comes to operating the network. And then as we have kind of evolved, firmware upgrades is something that we've added recently as well. So ability for the enterprises to go and configure an upgrade for an edge cluster, for a specific site, create a maintenance window and just do it on their own without having to rely on Celona is something that's now available to them as a self-service workflow. We talked about APIs, so they can generate an API key here. They can use that to then subscribe for alerts. But then all the data that you're seeing in the product, both monitoring and management, is all available via the REST API. So you can use this API key to pull those out. The subscriptions here, again, this is what I said about zero-touch inventory bring up. So once a customer makes a PO, they get an activation code. They use the activation code and pull down all the inventory that belongs to them. And then they go through the process of creating a site and then bringing up the APs in the edge cluster without ever having to touch these individual devices and network equipment. Single sign-on, again, having the ability for enterprises to use their own identity provider. So it's a SAML v2-based single sign-on system, which they can then use to make sure that they're adhering to their password policies or multi-factor authentication, whatever they might have. So some of these pieces are coming in as we get into production networks, we start talking to the security teams. These are all requirements that are kind of table stakes for an enterprise network. And device management, I know we have shown this before, but the full, and when you talk about device, for us a device is, as I said, a combination of the actual device and then the SIM card that goes on it. So that's the combination that kind of makes up the device. And the ability for you to manage the full life cycle of the SIM, activating it, deactivating it. We have also been able to, and this feature came in with, let me just add this. So the ability to lock the SIM to a specific device. So as enterprises are getting accustomed to deploying private wireless network, their security teams are starting to wonder if there are any gaps. And when it comes to physical SIMs, their basic question was, can I just pop the SIM out of one of the devices and then just put it on, somebody puts it on another device? How do you stop that from happening? And obviously you can't stop that physically, but you could do that in software, right? You could basically say, hey, lock this particular SIM card with this particular device IMEI. And you do that either by explicitly specifying what the IMEI of the device is, or you could say, hey, upon first attach, automatically learn what the mapping is. And then in the future, if there's any unauthorized access using that SIM card, alert me and make sure the device gets deactivated so it doesn't have any access on the network. So these are things that over time you keep adding based on the discussions that you have from customers and the learnings that you actually have.
Would love to see an alert without deactivate.
Sorry?
Would love to see an alert without a deactivate.
So that's a policy that you can define.
Oh,
so
good.
you can basically say that, hey, I just want to get alerted because I don't want to stop operations. I just want to get alerted. And then based on that alert, you can decide whether you want to act on it or not.
Dispatch the security team, go haul them away. Yeah.
Yeah.
This looks a whole lot better than your first couple of
I'm sure.
versions
So
of the
we
UI.
did go through a whole design rehaul end of last year. It's a labor of love from Asha, our designer, and our UI and UX team. They've been working quite a bit on kind of just using better charts and just better organization of data.
Yeah.
And now that we have that baseline, I think it's allowing us to add more analytics and more monitoring capabilities that is going to be very, very useful for our customers.
So I'm assuming we're going to get into it as we talk about integration with NAC, upstream NAC. But the Celona defined MAC address, is that married to a device permanently, or does that change as a device connects and disconnects from the network?
Yeah, so it's permanently to the SIM, right? So it's basically the first 6, if you think about it, the first 6 bytes. Then the reason why that came about was because, again, we are plugging into the enterprise L2 network, and that's one of the secret sauce that he said, okay, this thing needs to have a MAC address because you're plugging into the L2 network. And typically, cellular being L3, you don't have any identifier that you can use. So we created a cellular MAC or a Celona MAC address with a combination of Celona OUI and the 6 bytes of the SIM card identifier. So it basically ties to the SIM card.
In your deployments, one of the big advantages of cellular is the SIM and the more secure environment. Are you finding that your deployments have actually benefited from that, or are they finding the administration of the SIM to be burdensome? I mean,
I would say once you educate them, they do understand the benefits of SIM authentication and SIM-based mutual authentication, the security that comes with it. But the operational challenges are obvious, right? Like the logistics of having to take a SIM, send it to people, connect it. And so that's obviously something that I think there is a lot of room for innovation there. So one of the things that we have done is try to kind of create a single pane of glass so that they can do the entire SIM management here. They don't have to go to another system. In some cases, you actually have to go to a completely different system to do SIM management. So that's one part of it, at least from a network administrator perspective. But from an end user perspective, we are working very closely with all the device vendors to say, okay, eSIM is probably the right answer, Avril, there, where how can you make it zero touch? But even today, for eSIMs, you need to make sure that the device actually has some connectivity to go and pull down the eSIM from the internet. So how do you kind of create a bootstrap net? So there are a lot of discussions that we are having that can actually make the whole out-of-the-box experience completely seamless while retaining the security framework that SIM card actually brings to the table. So I would say today there are operational challenges and it is burdensome for them, but I think we are giving them a roadmap, or we are showing them a roadmap that kind of helps us hopefully in the next 6, 9, 12 months as more and more devices start to show up with eSIM. All of these devices have eSIM, by the way. Right. And 2 of them are actually connected via eSIM today. So as we see more of that, I feel that we'll get to a point where it's a thing of the past.
I find it interesting because a lot of what we've heard is on the Wi-Fi side, a user agent, visibility into the device is problematic. And in the cellular world, you have visibility and it's problematic from an administrative perspective. So you see that kind of crossover there.
No, absolutely.
For your remote AP support, what do you see kind of envisioned of, will I be able to deploy just the AP and then any required function can go to the cloud? Will I still need any of the physical hardware, maybe in a data center as opposed to...
Yeah, I would say that you would still need the control plane to be running on-premise to support the kind of mobility and latency that you need. You could potentially, depending on the use case, drop all the traffic data plane completely locally. That's possible. Again, you can define that based on policy. And based on your device traffic profile, you can decide to drop everything locally or push some of them. But you will end up, in my head, having the Celona edge in some form to start with, maybe the appliance in a data center. But over time, as the compute architecture and compute stories for enterprises evolves, you could basically, because I think 2 years ago, we showed Celona edge being deployed on a VM, on AWS, on Azure, on a private stack edge compute box. So we have shown all of that to be possible because it's a microservices-based architecture. We haven't seen that really play out in production because most customers so far just want the appliance and want to deploy that because the teams that we are dealing with either don't have access to compute, it's a different team, and it's just too much of hassle and all of that. And they would rather, when they're deploying a mission-critical network, they like the security of having a box that is dedicated for it. But over time, I'm expecting that as these kind of silos merge, the edge operating system is what we call it, the software, can actually be deployed on a compute infrastructure that the customer brings to the table.
Yeah, I'm thinking of those highly distributed facilities where I just want one outdoor AP.
Yeah.
And I don't need it.
And you could basically just spin up maybe of all your app, and you could just have a Celona Edge operating system running on your AWS or Azure or wherever your cloud is, and then you can drop all the traffic locally, and the control plane can be in the cloud.
Perfect. Thank you.
So I think that's the world we'll eventually move to, but I don't think the enterprises are there yet.